Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will be discussing yet another famous algorithm which is asked in multiple interviews called sliding window algorithm. So let's dive into it. This sliding window algorithm uses two-pointer technique, which is nothing but creating a window that consists of two pointers. Let's say we created this window in this array, and so we would need two pointers. So let's say this is your pointer 1 and this is your pointer 2. Let's name it as start pointer and let's call it as end pointer. One thing about sliding window algorithm is that it is only applicable on arrays. It is only applicable on arrays. And we know that we have to create a window like which I discussed earlier. So let's take one example. So this is an array. Let's take this array. And there are certain elements in that. Let's index it at 0, 1, 2 and n minus 1. So in sliding window we first create a valid window based on the problem description, and then we keep on sliding it in order to get the most optimal result, right? And then out of all these valid window, these are your valid window, these are your valid windows. Take the most optimal one. Take the most optimal one, right? Now let's take one example to understand this sliding window algorithm completely. So we'll take this problem and we'll try to solve this problem using sliding window. So the problem description says you are given a string s, you have to find the longest substring without a repeating character. And let's take this example. In this example, if you look at the max possible substring without a repeating character are ABC or BCA or CAB, right? So there are multiple possible substring without a repeating character, but you have to return the maximum length. You don't have to return the exact substring because there could be multiple of them, right? So just return the max possible substring length without a repeating character. So let's see how we can approach this problem using sliding window. Let's take first test case. The first test case was ABC, ABC, BB. So in sliding window, as I already discussed, we first create the first window, first valid window. So here valid means no repeating character. No repeating character. This is the definition of a valid substring. So we first create the first valid substring. So if you look at this window, so this is my first window, and in sliding window algorithm we keep on sliding it in order to get the most optimal result. And here the most optimal result which you have to find is the max length. The max length of a valid window, or I could call it substring. And we know what is the definition of valid. The definition of valid says that the characters should not be repeated. Let's see how we can approach for this problem. We will need a frequency array to store the frequency of each characters in a valid window. Since there are just 3 characters, so let's take a frequency array of size 3, A, B and C. This is my frequency array, right? And the initial frequency of each character is 0. Then we will take first window. This is my first window that consists of just one character, which is A. Then we will update the frequency of A, which is 1. Then what we will do, we will try to increase the window size because we have to find the maximum length, right? So this is my initial valid window. My start index is 0 and end index is 0. The indexing is 0, 1, 2 till n minus 1. This is my start index, this is my end index. We will try to include the second character in my current window. We will check whether this character has already been seen or not. So just check the frequency. If its frequency is 0, it means that this has not been seen earlier, so you can include it. So increase your window size. So now your window size is this one. Your start index is 0 and end index is 1. And then change the frequency of B from 0 to 1. Again we will do the same process for character C. We will go and check whether C has been seen earlier or not. Since the frequency of C is 0, it means that this has not been seen earlier, so include that in my current window. If you include character C into your current window, your start would become 0 and end would become 2. And then again, like, increment the frequency of character C from 0 to 1. Now we will come to fourth character, which is A. So again we will try to include the fourth character, which is A, into my current window, and for that reason we will go and check the frequency of A, which is already 1. Means that this character has already been seen, and which is already included into my current window. So my current window consists of A, B, C, and then when you try to include A here, your A will be repeated, right? It means that you have to remove all these characters which is before A to get the new window. So your new window will look like B, C and A. So your start will become 1 and end will become 3. Again you will do the same process for character B. So before this your window was B, C and A. You will, when you try to include B, again B will be repeated since the character of B is 1, and so you will go and keep on removing all the characters which is before B. So just remove these characters, then your window will become C, A, B, C, A and B. So your start will become 2 and end will become 4. And no need to update your frequencies, because the frequency is anyway 1 in all the cases. CAB also consists of frequency 1, 1, 1 for all 3 characters. Again you come and C for C. If you try to include C here, again C will be repeated. Just remove these characters from here, then your window would become A, B and C. So start will be 3 and end will be 5. Again you come for B. So once you do that, so this is my current substring, and when you try to include B here, your B will be again repeated, right? So you go and remove all these characters which are before B. So remove A and B, so your character would become C and B. So now the frequency of A has already been removed, so update the frequency of A from 1 to 0. So 0, 1, 1 is my current frequency array. So and your start would become 5 and end will become 6. Again you come for the last character. So this is my current window. If you include B here, your B will be repeated. It means that you have to remove all the characters which are before B. So just remove C and B. So once you do that, your start will become 7 and end will become 7, right? Once you do that, and your frequency array will, again, since C has already been removed, update the frequency of C from 1 to 0, right? So this is my frequency array at the end, and this is my start index and end index. If you look at the length of each valid substring, this is 1, this is 2, this is 3, this is 3, this is 3, this is 3, this is 2, this is 1. So these are all possible valid window or substring, I could call it, and the max of those is 3. 3 is the maximum. 3. So this is my answer, max length. So let's see how we can write code for it. Let's look at the code now. We first took the size of the string, Then we check whether the string is empty or not. If the string is empty, just return 0. Then we taken a frequency array of size 256. 256 because the problem description says that the string may consist of letter, digit, symbol and spaces, right? And the maximum ASCII value of the alphanumeric characters are 255. So for that reason I need to take the frequency array of size 256. Then I take the first valid window of length 1 that consists of just the first character itself. So your start index is 0 and end index is 0. Then you increment the frequency of that character by 1, and so far the max substring length is 1 because there is just one character in my current valid substring. Then you go to the next character, and we know that if this is your start and this is your end, then your next character is going to be end plus 1. So we just need to check whether the next character is inside the array or not. So if int plus 1 is less than n, it means that the next character is inside the array. Then what we do, we increment the int. Then we check whether the current character is already been seen or not. To check that, just check the frequency. If the frequency is 1, it means that my current frequency is already 1. Means this is a repeated character, right? This is a repeated character. Then what we do, we keep on removing all the characters before the first occurrence of the current character. So while s of start is not equal to s of end, you keep on removing all those characters. So we decrement the frequency of that character and we increment the start. So we keep on doing that until we reach the first occurrence of the current character. And at the end, your start must be less than end because the both characters are same, so the length will at least be 2, so the start would be less than end. Then we increment the start to get the new window, right? And else condition, the else condition would hit if this character is a unique character, if your current character is a unique character. So you just increment the frequency of your current character and update the maximum valid substring length, and at the end of this function just return the maximum substring length. So this way you can get the maximum length among all possible valid substring, right? Yeah, so if you find the video helpful, please like and subscribe to my channel. Thanks for watching.